Alright, this one's really interesting. Impulse momentum theorem. To find how long a stone falling straight down takes to increase its speed. So we have a change in velocity, obviously. So what we're going to do is let's look at this as force times time equals mass times change in velocity. Again, we've been there, done that. The force of a stone is really the weight of the stone. So it's mass times gravity. That's my force. Times time, or change in time, but it would just be the change. And the mass times the change in velocity, 10.4 minus 5.5 is a 4.9 meter per second change, right? It's change in velocity. I just subtracted these two numbers to get that 4.9. If we want to get time all by itself, we'd have to divide that mg out of there. So this is mass times 4.9 meters per second divided by mg by m. The time would be 4.9 meters per second divided by gravity, which is 9.8 meters per second squared. When these units combine, I'm going to be just left with seconds, which is really nice. Remember, this would be seconds squared over meters, and I have meters over seconds already. Bye-bye, I'm left with seconds. So that's really nice how that works. 4.9, if you can't see it by looking at it, 4.9 divided by 9.8 is half. So half a second. Which makes sense, because if you look at 4.9, that's half of 9.8. This 4.9 came from change in velocity. As a stone falls, it changes its velocity 9.8 meters per second for every 1 second, so to change half of that would be half a second. Woo-woo. Woo-woo.